Hi, Spring fans. Welcome to another installment of Spring Tips. As always, I'm happy to join you today. I, uh, uh, I'm excited about today's topic, actually, if I'm honest. We're going to talk about Kotlin, and in particular, we're gonna revisit Kotlin. We've already talked about Kotlin a number of times on this humble screencast of ours, but we're gonna focus in particular on coroutines. Now, the reason I've waited this long to talk about it is because I wanted to get it right, and things were kind of in flux, if you will, when I looked at it a few times. And finally, Kotlin 1.3 has been released, and with it, the core support for Kotlin itself has been made sort of generally available. Now, there are some other things that are not quite generally available, and you're going to see that I'm going to pull in some pieces that are not yet final, but they're relatively stable, and people are using them, and to great effect. And you'll find, and even one particularly nice aspect of the of that stability is that when I was looking for ideas or documentation and things like that on the internet, I found answers that were fairly applicable. Right, most of the time it was applicable. So this tells me that it has remained stable long enough for there to be a corpus of work talking about it. And that's to the credit of the team working on Kotlin itself. For those of you who listen to my little podcast, a beautiful podcast, available, of course, on all on all platforms where podcasts are downloaded, available through all popular podcatchers, including Apple, iTunes. I guess it's iTunes, Google Play, and of course Spotify. For those of you who listen to that, I even had the privilege of interviewing the Kotlin team's Roman Lizarov a few weeks ago, and that interview was absolutely fascinating. So if you want a lot more background on what we're going to talk about today, if you want a lot more detail on what we're going to talk about today, then you should absolutely listen to that podcast. And while you're at it, please subscribe. But we're going to see what that looks like, what that translates into as we build an application today using Kotlin. We're going to use the latest and greatest Spring Boot 2.203, M3 rather. We're just going to call this Coroutines. All right, see what I did there? I swapped the K for a C. So that's cool. So we're going to use reactive web support. We're going to use the reactive MongoDB support. We're going to use. I guess that's it. I guess that's it. That's most of what we're going to need that I can get from the initializer. We can use MongoDB. Yeah, we can use MongoDB. The nice thing is we can also use R2DBC, and I think we will do that as well. But keep in mind, you don't have to. Well, first of all, there's no checkbox here, but there is, as we saw in a previous video, experimental support, experimental auto configuration support for that. So maybe we'll get to it. We'll see if I can. I don't know. Either way, know that you can, and most of what you're going to see today also applies there. Obviously, there's a different domain model and different data type, but the extension functions that we're going to introduce that are applicable to MongoDB are similarly applicable to R2DBC. Okay, so we're going to hit generate. That'll give us a new project, and I'll open this up. And by the way, can we take a moment to appreciate just how amazing this brand new snazzy React-based Spring Initializer is? Look at that. That's you don't even know where the code is, right? It's just all really nice looking React.js and stuff. A little hard to penetrate in terms of parsing it by hand, by eye, but awesome stuff are happening there. That's cool. So it's really fast, Okay. Anyway, here we go. Open that up. All right. And as soon as this is loaded, the first thing that we're going to take a look at is bringing in the right dependencies to make this work. Okay, so we'll close that out. Good. Alrighty, come on. Does this one already exist? Okay, good stuff. So, we're going to build an application. Here we go. And before we get too far down the line, of course, we have to add the right dependencies and configure the right things to make this work. So the first thing I want to do is pull the version of Kotlin, make sure that's at 1.3 something, 3.1 is fine. And then we want to specify a version for the Kotlin Coroutines library. So Kotlin X Coroutines. This is sort of like an incubator library outside of the main support for Kotlin outside of the main support for coroutines in Kotlin. And by the way, that's by design. One of the really well designed aspects of the support for Kotlin coroutines is that I think there's one keyword, suspend. I think that's the only thing that's unique. Everything else is designed as functions, right? And the model is actually flexible enough that you can use it as a sort of generator, or you can use it as a sort of async await, a la C# in 2012. And so it's really nice that they were able to implement such a flexible foundational thing and then defer to third-party libraries to plug in the gaps in whatever way they would see fit. And that really has come out nicely in this API. So we'll see that here. We're going to actually see that in this library. So okay, what do we got? We got dependency. We want Kotlin X coroutines reactor. Okay, so you can see we've got an adapter for reactor. Okay, I'll get back to that in a second. And the version, of course, is a property. So Kotlin Coroutines version. All right, good stuff. Copy that. And we've got Kotlin Coroutines version for core. Right, here we are as well. Good stuff. Okay, so we've got the core bits there. I guess we could do R2DBC. I'll just bring them in, and we'll maybe use them, maybe we won't. You know what I'm saying? Copy. Add that in. We need the dependency management section down there. Okay. I want to connect to my trusty Postgres database there. Good. And we need to, I think I'll do it with R2DBC. I'll get rid of MongoDB because I just like R2DBC so much. Okay. Good stuff. And now in our code, we'll revisit all this stuff in a minute, but in our code, let's comment out Spring Boot for the moment. And we're going to focus on first of all, let's see if we can get the basic code working, okay? So we're going to create a function or two that'll help us in our work here. We're going to comment this out and create a function here that'll log data to the... We're going to create a function that'll log stuff out. We need to record the current thread .name, and we'll record a message if it's given to us, and there we go. And that'll be useful. And then we'll also record the current time, right? So instant .now. Alrighty, and there we go. So now we've got a thing we can use to take notes, and it's just a function. It's just a public static void main Kotlin program, irregardless, of Spring or anything like that. And then we can explore the ideas behind coroutines. Okay, that's really what I want to focus on. Nice thing in 1.3. Look at that. Don't even need this anymore. Kind of cool. I'm a fan. Let's see. Do we have we're going to be using a preview version of Flow from Kotlin Coroutines, and this annotation tells IntelliJ just to leave us alone when we, to not bother us with this reminder that it's a experimental, right? Very convenient. And we're going to experiment with coroutines. Now coroutines, let's ground what we're doing here in some background. First of all, coroutines are a way to approach asynchronous programming. Okay, they are a way to move work off of the current thread. Now there's a lot of ways to do that, right? A lot of ways to do that, but you can create a thread yourself and move that work into the background. You can use deferred or promises APIs or completable futures, things like that. That certainly works as well. The problem with this, and you can even use reactive types, and I quite like reactive types. Obviously, you see me talking about that quite a bit. Those types are, we're going to actually use those reactive types, but we're going to use them through this Coroutine API. What the Coroutines do is they give us a way to tell the language, hey, here's a thing that I want to run asynchronously, but I want to resume execution of code as though I was running it synchronously. And the way this works is that when you create a function, let's say, do something async, like this. Okay, this is not a coroutine. This is not a suspendable thing. When you do this, and then you say, okay, val a equals 1, and then you say return string, whatever. I'm just creating a dummy thing like that. Okay, hello. You say val message equals do something async, and then you say val b equals 2. If you were to run this code, nothing would be special about this, but you can run this. Well, you don't need to in this case. You can run this on a separate thread, and of course, what I want to happen here is, hello, whatever parameter. What I want to happen is that we get to this line in the code, then we get to this line, and then this code, this main method, for all intents and purposes, it stops here. All right. What happens is execution moves over to this do async something, do something async function, and the state, the sort of the things that we have to do out here after here, print line, all that stuff, print line, blah, all that stuff gets wrapped up in a lambda, right? Like this, val callback. Okay, fun, like that, right? And this callback gets passed in to this function. So really, it's the compiler helps us out by writing this code for us. It passes in the callback, and then after the function has finished, it makes sure that we have, what is it, string, right? It makes sure that after we're done with the business logic here, of whatever we're trying to do, that something calls the callback and allows it to complete after this line. And so the effect, is that not the, unit. I don't know what it's doing there. The effect of that is that it looks from our perspective as something that's written in this way. It looks like this executed, then the do something async happened, and then and only then val b equals 2 and print line happened. It happens in that order. But what is actually happening is that there's this fancy state that's being passed into the function, and it's being kept for after the business logic is done. It's being called, and then it looks like it returned back to where you started. So you had 3 lines before. In the order that you have it there, it still very much feels like 3 lines. It feels like you've got A, some logic here, and then B, right? And B is the thing that happens afterwards. That's awesome, right? And that state here, I'm using a lambda to kind of demonstrate the idea here, but that's called a continuation, right? It's actually an object that gets inserted for you by the compiler when it sees that you've got functionality that should be suspendable. Now, this isn't suspendable. What I've just shown you here isn't actually suspendable. In order for you to tell the compiler that something is suspendable, first of all, you have to mark it with suspend, right? That's a fancy keyword. Now, you can see that there's nothing here. You can see that this isn't special, right? I haven't actually done anything that's suspendable yet. And the reason is because if I were to run something that is time intensive, right, in this code, it would sit there and block. It would sit there just like anything else. If I tried to do thread.sleep, for example, well, you can see the tool would tell me, uh-oh, that's not good. It's inappropriate use. And also I'm returning there. It's inappropriate use of a blocking API. But really, the result would be the same. If you were to call this code like this, even though it's marked as suspend, this would block, right? What you would have to do is to use with context, right? Context, is it? With with context. You have to use something. I forget the name of the API, and it isn't all that much matter. I don't really want to get too much into that, but you have to use something to teach the runtime how to make this thing asynchronous, right? How do you figure out when how do you figure out how to start it, and how do you figure out what it looks like when it's done? And that's, I think it's called with context or something like that. The result is that you're actually teaching the runtime how to make this thing that is blocking. You're teaching it what part you can launch in the background and what it looks like when it's done, and then it can just treat that as an asynchronous thing, right? And you can also move that onto a thread. Basically, you're moving it onto a scheduler, so that with context thing does that for you, right? So most of the time you won't have to worry about that. You won't have to. Hopefully, most of the time you're not going to be worrying about how to make things that are synchronous feel asynchronous through this adapter code. What is important to understand is that there are a lot of functions, a lot of API calls that you can make in Kotlin proper, in Kotlin X, and in Spring in general that already support this and do this for you. So reactive code that uses publishers, that uses these things that are that you can start and then that have a known way to finish. You know, you can subscribe and get the results, and they emit items. We can generically adapt a publisher into something that looks like a suspendable function for Kotlin. And so we've done that for you automatically, right, in a lot of different places throughout the Spring sort of ecosystem. Now this support, a lot of it originally debuted in Spring Foo, our micro framework, and I did a Spring Tip video on that a while back as well. Spring Foo looks at a number of these different APIs, I'm not sure if we even introduced coroutines there, but the point is it's super easy to do with coroutines. So now that you kind of understand the idea, that you've got this suspendable keyword that you can use for functions that in turn also call things that are non-blocking, now you've got, I hope you've got an idea for what's possible. Now let's look at what that looks like in practice. Let's write some basic coroutine code to get an idea for what it is. Let's say I want to launch some asynchronous behavior, okay? So I'm going to note, I'll create a bunch of functions. One here, and I'll say one, okay? And I'll say, I want to call it delay. This is a non-blocking thread sleep, okay? So I'll say, I want to sleep for 1 second, okay? But in order to call that, this is the compiler error saying, hey, you can't do that. You need to call it from a coroutine or another suspendable function, okay? So I'm going to do that within the context of a coroutine. I'll say global scope dot launch, and then run that. So now I've called launch. If you look at the documentation for launch, this only launches, it just launches a new coroutine without blocking the current thread, and it returns a reference as a job. Okay, so I'm actually val job. Whoop. Why can't I type job? Okay, now I can say cancel, right? I can cancel if I want. I can cancel and join. I can cancel the children, like the other coroutines inside of it. I can do all sorts of things here if I want. In which case it'll stop. So that's kind of interesting, isn't it? You've got now a way to sort of stop a asynchronous thing. As it is, though, it'll already do something interesting. So let's see what this is, right? I'm going to note the end of one, okay? I'm going to note the results, and then I'll note that I'm going to start here, okay? So let's see what that looks like. Okay. Did I do something? Start. You shouldn't need to do that though. Oh, you know what happened? I know what happened. It's asynchronous. It's obvious. So I'm going to make the program as a general thing. No matter what examples I do, I want them to sleep for 10 seconds. so that it doesn't kill the process before any asynchronous outstanding threads have had the chance to run. So we started at this time, okay, 7 o'clock 3 minutes, 15 seconds, all right? And we're expecting it to sleep. Oh, I actually made it sleep for 10 seconds. So it actually ran a little longer because we only gave it 10 seconds in general. I should make this 20 just in case I make that mistake again. So there you go. You can see it completed. Let's make that 20. And you can see it completed on a different thread, all right? That's fairly straightforward, right? I'm launching code in here, and if I have something that is suspendable, I can launch it inside of this as well. Okay, so that's one. What about, let's look at another example. 2. Okay, I'm just going to keep creating functions inside of functions because it's Kotlin, it's awesome, and I can. Now, what if I want to have, you can see that in this case, in number 1, this is obviously asynchronous. It's like a thread. It's like I created a new thread, and it stopped, it finished after I started, basically. But what if I want things to run linearly? Like I want to have ABC. I want to be able to say, run this asynchronously and then run ABC. Well, I can use run blocking. And this is what I would use inside of main code. This is a great way to adapt suspendable code to main code, right? You probably use this at the top level of your application, and then everything after that is suspendable function. So here I'm going to say note to start, okay, note to stop, and here what I'm going to do in here, I'm going to delay 2 seconds, and I'll note run blocking, to blocking end and start. All right, and we need to run 2. I have to invoke it. Okay. Okay, so to start, blocking end, right? So I'm inside the blocking end, and the delay happened. So you can see it says 29, blah, 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 and then 31. Okay, so I stopped for 2 seconds, and then it finished. In this case, things are linear, right? They're linear. They actually proceed as though we want them to, right? And that's good. That's actually, that gives you the ability to force things to happen to sit in a certain sequence if you're unsure about them. Now, what about 3? What's the next example here? Fun. 3. Here, we're going to look at async, okay? So let's say I have a bunch of numbers, and I want to sum them together, okay? And this is an example I got from the documentation. I think it's quite illustrative, so I'll do it for you, okay? So deferred equals 1 1,000,000, okay? So I'm going to sum up each one. I'm going to create a range. This is a Kotlin syntax for creating a range, 1 to 1,000,000 numbers, okay? And then I'm going to map over each one. And in Kotlin, you specify a param, right, like that. Or you can just use the implicit variable it. That's from Groovy, for example. And so what I want to do is I want to return each item, each number, okay? But I'm going to sleep for a second. So let me just return num. But before I do that, I'm going to sleep for 1 second. And of course, in order to sleep, I need to run this code asynchronously, right? So actually, let's try this. Let's try doing thread.sleep. What happens here? Okay, so if I do thread.sleep, what do you think is going to happen? I'm gonna then go through this range. I'm going to say deferred dot sum by, right? And I'm going to say sum by and it, right? So the result, the total sum, is going to be the sum of all these numbers of all in the range. It's going to be a self. I'm just going to say take it and add it, right? I'm not going to do anything else. So it is each number in the thing. Well, what does that mean? What does it look like for us? Well, that means it's going to create 1,000,000 numbers, and each time it's going to sleep a second. I don't have that kind of time. I don't have 1,000,000 seconds to wait for this result, right? So I'm not even going to bother running this for you. We can run it for now. We can try. Note after sum. We'll never get there, right? Before sum. Okay. Sum. Okay, so that's not a good. It's not going to be a great result. We're not going to like what's happening here. But I'll let it run for half a second or two, or 5 or whatever. And you can maybe even hear my computer struggling because it doesn't like what's just happened, right? Okay, point made, right? So now, what if I wanted to do this? What if I wanted to add a million things, but I wanted to do this asynchronously? So that way I sleep, but I sleep without blocking the parent thread. In this case, I can do global scope dot async. And here, instead of using thread.sleep, which we have already established is inappropriate, I might as well use a summable thing. I'll do that, and I'll return none. All right. So now what I've got now is a deferred. All right. The result of calling async is a deferred of type t. Okay. And so in order to get the value now what I have is a sequence of deferreds. And so for each value, I need to call await. Okay. But of course, in order to call await, I need to be inside of a coroutine, right? Because I'm using deferred, so I need to also run this inside of a coroutine. So I'm going to say run blocking. So what has happened now? I've got a deferred collection. I'm visiting a million items, and I'm going to create a million, not threads, right? Lightweight fibers, kind of, not threads. I certainly wouldn't want to create a million threads on this machine. Oh, I need to call 3. I keep forgetting to do that. 3. So, good. There's the result. That's the number, right? If you take a million numbers and add them together, you get that, right? And it didn't take very long at all. It took 10, 22, 24, so 2 seconds to move work onto a number of carrier threads on the operating system, on the JVM. Not a million threads. It didn't create a million ones. It just very efficiently moved work on and off the threads so that I could do a million things as fast as possible, right? And because it had this async coroutine in here, and because we use the non-blocking version of this, as soon as it's sleeping, as soon as it slept, it told the runtime, hey, I'm no longer using this thread. Somebody else can use it. So while one finally made it to a million, while one finally made it to 1 second, it got the thread and then it was able to free itself up and somebody else was able to use it and so on. So it just kept going like that as fast as possible. This meant that all of the computations just took 2 seconds. That's very convenient, okay? Now, what about this one? Let's see. Right now I've shown you how to use deferred. Now deferred is great for a single value of data. Okay, a single value of data that you want to return. It's kind of like a completable future, but it works with coroutines, right? And you can see we're getting the same benefits here of asynchronous programming, but we're not really dealing with a lot of that complexity here. We're not doing countdown latches or cyclic barriers or phasers or semaphores or whatever, okay? So now I'm going to look at another example here. Now we're going to look at how do I solve the problem of having a lot of data, right? Obviously, a very simple example would be to use reactive code, right? You get a publisher, but publishers aren't by default aware of coroutines. They don't know how by default to they don't look synchronous, right? There's very clearly this sort of asynchronous behavior there, and so you can't write code that looks like synchronous blocking code. So what I'm going to do now is I'm going to introduce a new type called a flow. Okay, so here fun for, and here it'll be a for, and I'll say that I want to have a collection of integers, a flow of ints. Okay, and this is another example I think I got from the documentation or from one of Roman Elizarov's amazing blogs. Either way, worth visiting. And so a flow is kind of like a publisher, but with coroutines, okay? And so I'm going to create a flow here. I'm going to create a flow, and I'm going to emit values into this flow. And I can do this at whatever cadence I want. Very much like using flux.create in the reactive world, I'm creating a thing that will periodically emit values. So I'm going to say for I in 110, okay? Whoops. All right, and I'm going to sleep a second between each one, and then I'll emit an item. And now I've got a flow it's going to have 10 items, and I'm going to now iterate over that. But of course, in order to do that, I need to do this in the adapter glue layer here. And I'll say inst.collect. I'm going to log out the data, so note it. Okay, good stuff. And we're going to call for. Okay, so we're doing that. We're actually visiting the data. We're actually creating a flow that emits data periodically. The nice thing about that is that even though it's taking time, again, we're not sitting there on that thread, wasting that thread so that nobody else can use it. We can get off that thread, right? That's the benefit here. In this case, it's the main thread, but imagine some other thread in the thread pool. You want to get off of that in between the raindrops there, in between the emission of new data. And so you want somebody else to be able to reuse that. Now you can do that because delay doesn't block the client thread, the calling thread. Okay, 5. Here, I think it's time for us to look at how this all plays into Spring. Okay, so what I want to do is we're going to just create some data, right? We're going to create some data that will get launched in the normal way. So we'll say, well, first of all, 5, okay. And we're going to create a data class called a reservation. Val ID int name string, okay. Oh, val name string. And we want to have a class reservation repository. Alrighty. Val database client dbc. All right. And good stuff. Okay. So now I'm going to have a repository that's going to be using the R2DBC database client. I should make that private. That's good practice there. It's going to be a thing that uses the database client. And now what I want to do is I want to use the database client to call into my SQL data store. I've got Postgres running in the background. We need to configure a connection factory. So I'm going to run my Spring Boot application. I'm going to provide some configuration here. Val beans, okay. And okay, let's see here. We will create beans using the DSL and Kotlin for functional bean definitions. You don't have to use this. You can use Java config or whatever, but I quite like it, especially when in the Kotlin world. So I'm going to create a bean here for a connection factory. Connection factories. Sorry, bean. Connection factory. Dot get. And I'm going to reference my environment, my Spring Framework environment, and pull out the property here called spring.r2dbc.url, and that could be nullable, so I need to force it to realize that fact. All right, and there you go. That's my bean for the connection factory for R2dbc. I need a reservation repository. We might as well get that done right now. And I'll just use ref again to tell it to inject a reference to another bean. By type, it can infer based on reified generics that the parameter to this is database client, and so it can actually capture that. It's like being able to capture generic type information in Java, which you can't really do, but you can do it in Kotlin, kind of. Right? And then finally, we're going to create a web endpoint. We'll do that in a second, but let's get rid of that. I'm going to say add initializers. Oh no, we need to actually run the application. So I'll say run application, and the application is of type Coroutines. Okay, and we need to create that main class again. So here we go. Coroutines application. All right. Good stuff. Good stuff. Okay, so there's beans. There's the Coroutines application. And inside that, we need to add our initializers, and that's where we can pass in our beans functional initializer, functional bean registration initializer. And now, with that done, we can build a repository that supports common uses of our database, of our R2BC database. So I'm going to say suspend fun find one, okay, and I'm going to say give it a name string, and I want the results to be a reservation if possible. Now in Kotlin, reservations are nullable if you give them a question mark. So I'm going to say that I want this to be nullable, and I'm going to say I want to execute a query, and I want to find SQL. I'll say select all from reservation where name equals name. All right, and I want to bind a parameter name to name, and I'll say as type. I want this to be, I'm going to use the extension functions here, right, to capture that generic information, and I'm going to fetch it. Now what that returns is a fetch spec, and in the reactive world you just say all, and that would be it. That would give you a publisher of reservation, okay? But we're using the Kotlin API, and we can actually use these extension functions, including one or null. That'll actually take this, that'll turn this into a thing that resolves into a value, right? But when somebody calls this function, we're not going to sit there waiting for the value to materialize. It'll actually trigger the suspension of the thread, and when the data finally is available, then it'll resume, and it'll have that continuation, right? There's a continuation that'll get passed in here. So whatever comes before this function, whatever comes before the call into this function, will pick up right after it finishes, just as though it finished on the same thread. Okay, that's find one. And what about find all? What about all of it? Well, here I'm not using anything. I'm not going to do. What I'm going to do is I'm going to convert it into a flow. Okay, so what I want to do is I want to get all the values from the database. So I'm going to say dbc dot select dot from reservation dot as type, and the type will be, of course, reservation. And here I'm going to turn it into a flow. So flow is that thing I talked to you about before that supports iterating or working with a stream of asynchronous values, like a publisher. All right. So dot fetch dot flow. There's the extension function. Good stuff. Now we can use that, right? And what I want to do is I want to use this repository in building a REST API. And again, we have an opportunity here. So I'm going to build a router. And now you might remember that when I showed you this before, there's actually a DSL you can use for functional reactive HTTP endpoints, and there's an even nicer DSL in Kotlin. Well, if you want to do coroutine based web applications instead of reactive web applications, you can do that as well. And the only thing that switches up is, let's say I create a reference to this, I get a reference to my reservation repository. The only thing that switches up now is you use a co-router. Okay, so it's a coroutine router instead of a regular router. With that in place, you say reservations server response dot okay dot body, and we're not going to use body, we're going to use body flow. Okay, and in order to do that, I'm going to say rr dot all. Cool. And I'll say I want to get a particular one name. And by the way, body flow and await is an asynchronous. It's not asynchronous. It's an extension type, right? It's an extension function that was added to this type that doesn't exist there in the Java API. All praise the power of the Kotlin DSL for extensions. Okay. Then the body that we want to send back in this case is rr.find1, and the name will be the request parameter. So it is the request. It's the request actually. There's one parameter. It's called request. It's a server request, but I'm just going to use the implicit parameter called it. I'm going to find the data by its name, and if that data exists, great. If it doesn't, I'll just throw an illegal argument exception. Okay. So the name is not valid. Good. And then I'll send the response. Dot body and await. So now I'm just setting a single value, so I don't need the flow support there. But they're both, they're both powered by coroutines, which I think is super cool. Alrighty, so what did I do wrong? Oh, is it not this? There you go. Cool. Okay, so now let's try this one more time. Instead of calling 5, I'm going to call 6. Oh, it is 5. Yeah, 5. Never mind. Haha. Run. Alrighty. So, localhost, reservations. Good stuff, huh? There's our data. Get one particular record. That's working. Nice. So we've just used coroutine support baked into Spring in Kotlin. We've looked at. I mean, I'm not introducing hopefully anything too new to all of you. We've looked at previous things. We've looked at the functional reactive DSL in Kotlin before. We've looked at R2DBC before, right? We've looked at programmatic bean registration, functional bean registration before. We've looked at how to do reactive with the database client and with the reactive MongoDB template. And there are extension functions like .flow and so on the reactive MongoDB template and other templates as well. So again, hopefully none of this is super new to you. It's just that it all blends together really nicely in the world of coroutines and Kotlin. I really want to thank you for listening. I hope you got something out of this. Obviously, we've only just begun, right? The really interesting thing about this is not what we've done, but what we can do now, right? Kotlin coroutines are powered. Our support for coroutines, as you can see, are powered by these reactive types. And we're making huge inroads on supporting reactive as much as possible for all the sort of use cases that make sense. I'm excited, right? I'm excited to see what this portends for people that are building applications in Kotlin. I talk to a lot of people that want to use coroutines in Kotlin. They're just shocked when I show them all the support. There's a ton of people who are using Kotlin, and they use coroutines in Android. In that case, they don't want to block the main thread. Remember, in a UI framework like Android or Swing or something like that, it's super important that your code not languish on the UI thread. You need to get off of that thread so that the UI can paint itself as quickly as possible, so it can re-render itself. If you sit there waiting for data to download, things will freeze. So having a nice framework like this where you can write code that looks like it's synchronous and get the result that you're expecting, right? Like in this case, I can ask for a single record. I'm not getting a publisher back. I'm just getting a single record back. It looks like it's working that way. My code is written in that way, and I get that sort of determinism. I'm not worried about callback heck, going to callback hell. To be able to get that so easily, so nicely, that's a big deal. Now, of course, Kotlin support is fairly new, but this idea of coroutines is not new at all, right? I think C# was the first big language to have it back in 2012, right? So 7 years ago. And Python recently got it, right? Python 3.7, something like that, 3.6 maybe. It's a fairly new thing there, async await. Other languages have similar things, right? And I'm just really excited to see what this portends for us as a community, because obviously, while we're far different from an Android use case where a lot of people are using Kotlin, we all know that it's super important that you not block, block threads on a server, because threads are expensive. They're an expensive resource. So stay tuned, my friends, and as always, thanks so much for watching.